Hi, welcome back. And today we are going to see about the direct inspection method. So, what is direct inspection method? So, it is a straightforward technique which is used to construct the bus admittance matrix by visually inspecting the network diagram. So here you may consider the IEEE bus system. It may be 7 bus system, 11 bus system, 30 bus system, 15 bus system, or whatever it may be. So by visually inspecting the network diagram, we have to construct the bus admittance matrix, or it may be bus impedance matrix. So this direct forward method is called direct inspection method. So here there is no complex calculation needed at initial conditions, and here we can able to observe the network topology, and we can able to identify the bus connections, whether it's slack bus, generator bus, or it may be load bus, etc. And we can able to apply the simple rules so that we can able to form the direct inspection matrix. So here, so the direct inspection rules. First one, the diagonal elements like y11, y22, y33, y44, like this kind of diagonal element, it will be sum of all admittance which is connected to the particular buses. So for example, if you have taken the first bus system, that is Y11, if it is go for second bus, it is called Y22, etc. So here we can add all the admittance which is connected to that particular bus. That is called a diagonal element. And other than the diagonal element, that is called off diagonal element, like the branches between the bus 1 and 2, 2 and 3, 3 and 4, and 4 and 1, etc. So here the negative of admittance connecting between the two buses. So here we have to note down the what is the admittance between the two buses, and we have to make a sign change. We have to make a sign change. So other than the diagonal, that is called off diagonal element. If there is no connection, simply we can imagine it is called as zero. If there is no direct branch between the two branches, it will be called as zero. So this is the rules we have to follow while forming the direct inspection method. Okay, so here, so this is a single line diagram, or it may be called an one line diagram of a 4 bus system. So because here it consists of 4 buses, like this is in bus number 1, and this is in bus number 2, and this is in bus number 3, and this is in bus number 4. So in the it has the 4 bus system, and it has the 4 generator, like generator 1, generator 2, generator 3, and generator 4. And these are the static loads. The static load 1, static load 2, static load 3, and static load 4. So in some places it may contain only one load, and in few of places it may be contain several loads also. Okay, so this is called a branch between the bus 1 and 3 and bus 2 and 3, like that. So here we have to define. So what is the why we have to form the bus admittance matrix, and how we have to construct the admittance matrix efficiently for moderate sized or large sized network. So here we have to maintain the accuracy throughout the operations. So we are in need of the following requirements, like the speed should be very high, efficiency also should be high, and minimal computation should be there, so that only the time will be very less. And it should have the visual clarity to refer all those to verify all the answers, and we have to reduce the error detection. So what is the constraint we have to follow for the direct inspection method? Network size limit, and assume the known admittances, and manual inspection feasible, and clean network topology. So at the ideate stage, So at step number 1, we have to draw the network diagram. Suppose it may be the given, it may be like bus 1, bus 2, bus 3, transformer, generator, load, like that they are given this data. So from the data, we have to draw the network diagram. So it should be a single line diagram with labeled all buses, admittance, generators, loads, etc. So we have to draw the single line diagram, that is called draw the network. And in the step 2, we have to frame the matrix. So like n cross n matrix with the structure of n is nothing but n number of buses. If the bus is having the 4 buses, so it will be the 4 indicate the number of rows. So based on that, we can able to form the matrix sizes. Then we have to fix the what is the matrix size. And next, the diagonal terms. So for each buses, we have to add all the diagonal elements, and we have to put in the diagonal value. That is like y11, y22, y33, y44. And step number 4, we have to calculate and we have to determine the off diagonal element which is connected between any two buses, and we have to make a sign change. That is nothing but a negative of the mutual admittance between the connected buses. At the final stage, we have to verify whether the y12 which is equal to y21 for the passive networks. So these are the design procedure to construct the direct inspection method matrix. So this is a prototype. Here the system, it consists of 3 buses, that is bus number 1, bus number 2, bus number 3. Here the bus 1 is nothing but slack bus, and here it represents the P and V, so it is nothing but a generator bus, and this is nothing but it represents as a kilowatt and MVR, so that is nothing but real power and reactive power, so which is nothing but PQ load. So one is slack bus, one is generator bus, and another one is slack bus. So this is an branches or admittance value which is connected between the two branches. So here we have to take the admittance value y12, that is nothing but y denote the admittance which is between the bus 1 and 2, which is nothing but 5 per unit. So like that we have to measure all the data, and in the mesh in the bus number 1 there are 2 branches are connected, so we have to add the 2 admittance value, and bus number 2 the 2 branches are added, so just simply we have to add the 2 admittance value. In bus number 3 2 values are there, so just simply we have to add the 2 values so that we can able to form the admittance value. So based on the forming of this admittance, then just we can make into the matrix form. So how we have to validate? Because here we have to validate like the y14 which is equal to y41, the y23 which is equal to y32. So in the which is common between the 1 and 2, which is also same as 2 and 1. So like that we can able to verify whether the inspection method is right or wrong. So here the column row sum, in each row it should be equal to 0. So like that we can able to change it, and we can change the sign conversion for diagonal as positive and off diagonal as negative. And we have to check the dimension which is based on the matrix sizes and with respect to the number of buses. And these are the few applications which were used for load flow studies on the for symmetrical and asymmetrical fault analysis, and to maintain the system stability during the transient or dynamic conditions, and for the network optimization by using any of the fax devices, etc. So this is a concept of mind map by using the direct inspection method. So at initially we have to know the core concept, we have to inspect visually. Okay. The next step, we have to form the methodology. So we have to determine the diagonal element, and we have to determine the off diagonal element so that we can able to form the matrix. So from this matrix, so these are the advantages: the speed, simplicity, and it will be a very visual clarity. So this can be used for the load flow analysis, fault analysis, and stability studies, etc. So this is an curated challenge. Why does the direct inspection method become impractical for network with more than 10 buses? So if you know the answer, just you can comment in the comment section. And this is an assessment. Why is Ij taken a negative of the line admittance between buses I and J? So if you know the answer, just comment in the comment section. So these are the few textbook and reference books for this topic. Thank you.